Welcome to Milak Online tutorial. Now before us is this beautiful and interesting exponential equation, and it reads that if x is 6 raised to the power of x plus 6 raised to the power of y equals 42, and we are told that x plus y equals 3. So we are told to find the value of x and the value of y. Now looking at this, how do we start with? Now it looks confusing. However, we are told here that x plus y equals 3. Now from this equation here, I want to manufacture x plus y from either of these. Okay? And let's take note of this, that if you have a raised to the power of m, and you need to get a raised to the power of m plus n, all you just need to do is multiply here by a raised to the power of what? N. Okay? Okay. So that's what we're going to do. So since we are looking for x plus y, it means we can multiply 6 raised to the power of y to this term, this term, this term. And what we're multiplying through with all the time is to ensure that we balance the equation, both on the left hand side and on the right hand side. So let's get started. So here we have 6 raised to the power of x times 6 raised to the power of y. Now plus 6 raised to the power of y times 6 raised to the power of y, then equals 6 raised to the power of y, or 42. Okay? So applying the law of indices, so since we're having the same base, we can add the exponent. Just the same way here. So here we have 6 raised to the power of x plus y. Now plus 6 raised to the power of, now y plus y will give us what? 2y. So here we have 2y, then equals 6 raised to the power of y into 42. Okay, so since here we are given that x plus y equals 3, so we can replace x plus y for 3 here. We have 6 raised to the power of 3, okay, now plus 6 raised to the power of 2y, then equals 6 raised to the power of y into 42. Now looking at this, you see here we have 6 raised to the power of y, and here we can actually get 6 raised to the power of y by following this rule. If we have a raised to the power of mn, this can be written as a raised to the power of m, or raised to the power of what? N. So which means this term here can be written as y, or raised to the power of 2. Okay. However, this is 6 raised to the power of 3, which means 6 times 6 times 6. And that should be 6 times 6, that would be 36, times 6, that would be 216. So we can write this as 216, then plus 6 raised to the power of y, or raised to the power of 2, equals 6 raised to the power of y, or 42. Now we're having a term here, 6 raised to the power of y and 6 raised to the power of y, which we might not really be able to work with. However, we can do some sort of substitution here. Let's represent 6 raised to the power of y by a. So we can say here 6 raised to the power of y equals what? A. So wherever we see 6 raised to the power of y, we'll replace it by a. So here we have 216 plus a raised to the power of 2 equals, since we have in a here, we have 42a. Now it looks more like a quadratic equation here. So let us rearrange it and present it what? Clearly. So I want to bring 42 over to this place and rearrange it, then everything equals 0. So here we have, let me bring this a forward here. 42 over to the left hand side becomes minus 42, 42a. Then bringing, repositioning 216, we have plus 216 equals what? 0. And you can see it's now a quadratic equation, so we need to factorize. Okay, by factorizing, let me do this. Now what's two number? Since we're having a, and the leading coefficient here is 1, so here we have just a, and here we have what? A. Now since here we have minus and here we have plus, we have to make here minus and here what? Minus. So what are those two numbers in which we multiply that will give us 216, that's plus 216, and when you add them, will give us minus 42. and that is 36 and 6. So that will be minus 36 and minus 6. So since we are having a minus here already, you can just put 36 here and 6. So since this two term equals 0, it means either of the two is 0. I mean, either of it is 0 or both of them are 0. So here we have a minus 36 equals 0 and a minus 6 equals 0. So at this point now we can actually agree, let me clean this please. So we can agree here that a equals what, 36 here, and a equals what, 6 here, right? That's when we add 36 to both sides of the equation, a becomes 36. When we add 6 to both of the equation here, a becomes what, 6. More recall that a equals what, 6 raised to the power of 2. So for here, for a equals 36 here, we can say this is 6 raised to the power of y equals what, 36. Now since on the left hand side here we have a base of 6, and on the right hand side here we have a base of 36, let's just reduce the base of 36 to 6. That will give us 6 raised to the power of 2. So why I clean this and replace it with 6 raised to the power of 2. Sorry, this is just because of space. So y here will give us what, 2. Why? Because we have the same base, so it's logical that y will give us what, 2, because we have the same base. Okay, so for x equals to y, for a equals 6, so here we have that 6 raised to the power of y equals what, 6. Now since we are having the same base, automatically this is 1. So we can see here that y equals what, 1. Why? Because we have the same base both on the left and the right hand side, so we could just need to equate the exponent. So now since we have two equations, two solutions for y now, y equals to 2 and y equals to 1. Now let's take note from here that x plus y equals what, 3. So when y is 2, so here we have x plus 2 equals what, 3. Take 2 to this side, or subtract 2 from both sides, we have that x equals 1. Okay, so when y is 1, so that will be x plus y equals, let me just put 1 here, equals 3. So subtracting 1 from both sides, we end up having that x equals what, 2. So it implies that when y equals 2, x equals 1. When y equals 1, x equals what, 2. So these are the various values of x and y that satisfies the equation. Please don't go without sharing this video with others on various platforms. Thank you and God bless you. Bye bye.